Texas Friction 5, number 14 and 15. 14 is about a car moving along a horizontal road, and it gives you the givens, and you're going to find the shortest possible stopping distance for the car under such conditions. First, we'll pull out our givens, which are the mass, the velocity, coefficients of friction for both static and kinetic, that's a V, and of course our gravity is 9.8. So, and we're looking for x of s, x of f. So as we go down, we'll start with 4 equals force applied minus force. That's our big equation right there. Alright, so let me clear that, write a little smaller. Alright, so we can pull out the force net equals mass times acceleration. The force applied in this problem is 0, and then coefficient mass times gravity. Now we'll put in our givens that we had earlier, 810, which was the mass times acceleration, which we have to find before we can continue, equals 0 minus, we'll be doing the coefficient of static friction. The other coefficient we'll ignore, times 810, the mass again, times 9.8 gravity. And that will get us to equal, I'm out of room here, we'll go up, 810A equals negative 1,420.902 divided by 810 gives our acceleration negative 1.7542. That will bring us to using, I like to change up the color, force friction squared equals, velocity final squared equals velocity initial squared plus 2AD from beginning in the year. And we'll fill in that. Velocity final 0. Our velocity that was given is 26 squared plus 2. The acceleration is what we just found, which was negative 1.7542 times d. And that will be 676. So subtract from both sides. 676. Little room here. Up. So we got 676 equals to negative 1.7542 d. And we'll go ahead and do that. On both sides, that will give us the answer to the x of f, also d, which will be 192.68. Let me rewrite this. 192.6804. Alright, moving on. Question 15 for UTexas Friction 5. It's another one about a car. Pull out your givens once again, and you'll have mass similar to 14, except for you're just stopping after you find the acceleration. Velocity 11.7. Give you both coefficients again. You'll be using this one, and then coefficient of kinetic, and gravity 9.8. As we go down, we use the same formula again, which will also be NA equals 0, force applied is 0, minus coefficient of friction, mass times gravity. So as we get our points again, 8 equals 0, which we don't need. Don't forget the negative. 0.212 times mass times 9.8. Kind of cramped over there. So we'll do divided by 1800 on both sides. Get acceleration by itself. Do that in the calculator, and you'll get 2.0776 as your answer. That's UTexas Friction 5, questions 14 and 15.